So I think I'm recording now, and today we're going to continue with polymorphism. We're going to do some more cover of material, and then I have some plans for the lab portion of the class, which will include a new practice it exercise with polymorphism, the one with the Lord of the Rings. So I have posted a link to it. And then I'm going to give you time to work on the movie homework because it's the first week and I thought you might use some extra time. And also to just maybe warm up, and if you have any questions, you have all of us here to discuss the project. I think you'll find it very similar to what we did last quarter, close the polymorphic part of it, and Daniel has already finished it, so he will be available, our TA, and you're also TA, right?
Yes, ma'am.
I know, so the two, Daniel and Kira, will assist as well as necessary. So I like this definition of polymorphism, which I don't think I said last time, and it is the following. So making changes in the method definition of a derived class and then applying those changes to the base class. All right, so that's how you can think of it. So you're making it to the derived class, yet it's applied to the base class. How is that even possible? Because of late binding, right? So automatically behind the scenes, Java will do it because of late binding. So this is how it might be helpful to think about polymorphism. And an example to show how this works with a diagram. So this is a figure class, base class, and then we have the triangle shape, or shape, if you will, the triangle, circle, and rectangle inheriting from a figure or shape. And all these methods, they're going to draw on the screen the shape in question. So they all have a draw method, right? The implementation of each draw would be different for the different type of shape. And then the figure, we have a method center that will allow us to take the shape and maybe move it to the center of the screen, right? So you can take a shape and center it on the page. And this method will be permissible and used by all the derived classes. However, the center, in order to do what it's supposed to do, is going to need to draw, right? And so what is going to happen is, because of late binding, Java is going to make it so that the figure, when you call center, is going to know which shape to draw. Right? So it's like the magic of late binding. And I thought this is another way to describe polymorphism. I think it's helpful. Anything to add or questions? Okay. All right, so that's the diagram. Okay. Okay, so let's continue with some more material in the lecture, in the slides. And more specifically, we're going to continue on slide 18, if you're following on your machine.
Chapter 8.
We still, yes, so this week, chapter 8. Do you feel like you have a good understanding of polymorphism based on what we discussed so far? Great. I think I said it's a Latin root, but I think it's actually Greek, right? Poly is Greek. Excellent. again, let's see, no signal.
That's fine. That's my phone.
Oh, something is not plugged. Why would this not be plugged? This is a monitor. It appears to be pulled out from where though? Is it back here?
Oh, here. This one looks like this one's unplugged right here. This just fell apart.
Oh, yeah. Okay. Thanks.
Yeah, let me
Perfect.
I screw it in here for you. TV and mechanic.
All right, so we'll start with slide 18. I'll just click on that. So the toString method is available to us from where? From object. And so one way that we have been using polymorphism, but we haven't really talked about how it works, is that when we call the print line actually polymorphically can print the object that is further derived from the object instead of the object on the top of the hierarchy, right? And so this is another example of late binding. So you have system out print line, and then it's going to know when you say asale, it's actually polymorphically printing this object instead of the object class on the top of the hierarchy. And this is again because of late binding. And so how does this actually work? So what happens is that the print line is to take an object, but then you can, inside the object is going to take an object to string. So it's going to now become a string, and then it's going to print a string, right? And again, as we said many times, because of late binding, we're using the sale object as opposed to the object. Okay, next topic I wanted to touch on is upcast, downcasting, and maybe we should have talked about this before I let you do these practice it exercises. So with polymorphism, you can cast between this. Upcasting is if you have a derived class that you want to cast to a base class. Does it sound like an okay thing to do? Yes, it's an okay thing to do because the derived class is more specific than the base class, so there will be no loss of data or anything like that. So upcasting generally works without any problem. So it should be no problem to cast the discount sale to a sale class if that's necessary. And this would be upcast, so from derived to base. Downcasting is going to be from base to derived class. And this can be an example where it might not always work, and Java will not check for you if it works or not. So you might get some, Danny?
I was just going to ask, so when you go from derived to base and you're casting, do you lose any of the information that's only in the derived class?
So if you're going from derived to from a derived class has more data.
Yeah.
So if you want to cast it to a base class, then you're going to have the base class is less specific, right?
Yeah.
I wouldn't think
So-
that would lose information. You're just saying it's being able to treat it like that object, because otherwise you would have to reconstruct the object.
Right.
So It's the
You
same,
could
it's the
treat it.
same
It's
object.
almost like maybe you can think of it as a subset and a superset. Maybe that's more helpful how to think about it. Whereas if you're downcasting, then for example, the base class would not have certain methods or properties that are present in the derived class, and that would not work. Right? Let's see. So maybe I told those to you the difference. So the base is if the downcasting is if you're from base to derived, and this is a problem. Whereas if you're going from derived to base, there's no problem. That's right.
It can be a problem.
It can be. It might not be. In fact, we'll look at the case where it's necessary to do, but it can be a problem. And if it is a problem, it might give you, depending on the circumstance, a compile or a runtime error, right? So it's left to the programmer to use those with discretion, right? Okay, so here's an example where this would not work. So if you want to, if you have a, do you remember the example we did last time with a sale and the discount sale that inherits from it? And then we check whether the bill, which one is a better deal essentially, right? So with this example in mind, we have a discount variable and then you want to cast a sale variable, which is a base class, to a discount sale, and this will give you a runtime error. And then if you try to do it in this way, just assign one to the other, you get a compile error. And it's just a behavior to be aware of, right? And so when is downcasting necessary then? So when you're using the equals method where you want to check if two objects are the same, there may be a case where you need to, it's going to return an object, the equals returns an object and then you need to cast it to the object that you're actually working with. So in this case, you're downcasting, and this is a scenario where it would work, right? Okay. So the compiler might check, but will not necessarily check downcasting. And so there is a operator instance of that you can use to check whether one object can be cast into another. And this is going to return true or false. And then you can use if the else statement in your code before casting is to avoid an error occurring. So the instance of operator, I think there is an example with a Java Oracle documentation. It's actually a helpful page anyway. It has various different equality, relational, and conditional operators. And here is the example of using the instance of. Okay, so parent and child. So then you can check, does it show the output? Yes, it does. So is the object one an instance of the parent? Yes, it is. Is object one instance of the child? No, it's not. I don't know where this interface is coming from.
Where it says class parent.
Oh, down here. Oh, yeah, okay.
Google is.
Got it. So it's underneath. So we have a, so the child class extends parent and implements an interface. So is the interface, let's see, what is it doing here? Is the parent an instance of the interface? No, it's not, because it was implemented by the child.
Yeah.
And Do you want to run this example, or is it okay to just think about it? You can maybe. Would it be helpful to run this example?
So if we run it, it's just going to come out with that.
Yeah,
number,
exactly. So we'll just think about it. And so let's see. Then the other one is the object is the child an instance of the parent? It is. And is the interface an instance of the interface? Yes, it is. Does this make sense? Okay. So maybe I'll post this to our as a reference here. I think that's a good page with all these different ways of comparing and relating various components of the language. Quality, relations, and all right, so let's add it to week 1. So I think that, Damien, I misled a little bit because you're thinking about loss of information, but it's a different kind of relationship with the casting.
Yeah.
So I don't think we should think about it like that.
Yeah, I was just thinking that if there's additional, additional methods or something from the child class, if you cast it to the parent class, that it will retain all those or not.
An object in Java, the object will not change.
Yeah.
Yeah, it's the same object that is supposed to
Yeah. Okay, got it.
Right.
Just like telling the compiler, this is now this object.
Yeah.
Just think about it like this.
This is now the subject, right? Yeah. So I think I used words that led us down this discussion, but it's not the way we should think about it. Okay, so then this was the instance of operator. And then there is also the clone method, which is a method of the object class again. And what you do with the clone is, it's one of the ways, it's actually the preferred ways when you want to create a copy of your object. And the copy of the object created with a clone is going to have the same data as the original object. And when you're implementing clone by derived classes, the expectation is that you're going to overwrite and write your own code how to actually clone. And we'll talk more about it in a different chapter, 13. But this is what the clone object is. This brings the point with the covariant return type, which is available since Java 5, I believe. And so it will allow you to return an object or a different type after Java 5. So here, in this case, it's going to use the copy constructor and return. It will cast this to a sale type or discount type in the clone. Right, so before Java 5, you could only return an object, and now you can return, other types as well. So that's the discussion about polymorphism. And I was thinking we don't need to go over abstract classes again, unless there is interest. So what I'd like to do is I'm trying to make this class to be a lot more about coding than anything else, as you can see. And so here are my suggestions. I guess we're starting the lab pretty early. But I would like you, if you didn't finish the example from last time with 1, 2, 3, 4, then you can work on this. Then the next exercise I would like you to do is Frodo, Gandalf, and Bilbo and Gollum. And the links are posted under practice with coding exercises. And it will be similar to the other one. Feel free to talk with your neighbors as needed. Work on this, submit it, and then after that, you can start looking at the movie homework and work on the movie homework. And if you're done with all that, then let me know and I'll give you more work to do. All right? And for this one, we can maybe discuss it. It might be useful to discuss the practice exercises as a group, right?